Oh, it's just oh, I don't like the sound of that. Test. Yeah. Can you just record through the mic but not have the speakers on? Yeah? Cool. Yeah, because I don't need to. I can talk to you all. You can all hear me, right? I'll wait for Anton. Cool. Okay. So I'm just going to quickly say a few words, and then we'll get started. Stepan and Aleksa, they're going to run the workshop. Thanks to you guys for showing up. I know you could be many other places, but you're here with us, so that means a lot. Thanks for showing up. So this is a Devnet workshop. I think most of you know what Devnet is. We've spoken to most of you. We had about 300 people come to apply, and we've given you a little bit of what to expect. I'm going to quickly run that through, and then you're going to hear more from Aleksa and Stepan. So Devnet is the first release of NIL. It's the very simplest form of what we could share with you to start collecting user feedback. And that's what we're really looking for. We're looking for some feedback on the DevX around NIL. There's no ZK, there's no consensus happening, there's no networking or anything like that. It's all happening over a simulated environment. And what we want from you is the good, the bad, and the ugly, right? So our team has worked tirelessly over the last few months to ship this. We released zkSharding in last November. Our work started long before that. And a round of applause to our team. But I don't want you to feel bad about criticizing today, because that's what we're looking for. So despite all of that hard work, please just give us your honest feedback. Yeah. Yes, but thank you to the team, yeah. And I want to give a little bit of context about NIL, because I imagine many of you aren't really familiar with the company. But we've been around since 2018. Did a lot of low-level ZK infrastructure work, a lot of building circuits, and the company has evolved quite a bit over time. I know some of you know Proof Market or ZK LLVM or some of the other work that we've done with our partners. And now we have zkSharding and NIL. But despite all of that evolution, there's been common through lines through all of it. And two of them I want to point out. One is, and this is, I was chatting with one of our engineers the other day about, hey, what was it like early days of NIL? Why does this company exist? And what he said was, well, it started because we like to solve hard problems. And that was it. We like to work on hard things. And that is definitely still true today. The second is, in every sense of the term, we're crypto maximalists, right? We kind of have this crazy vision that a lot of the world's finance and markets and money and voting and trusted applications, they run on chain. And that's what we hope this can kind of be a step towards. Now, why an L2? Why, considering those two things, why are we building an L2? Well, we think that, clearly we're early adopters here, right? We have, 6 brave souls in this room who showed up. But if you look out more broadly in crypto, we're very much still in the early adopter phase. If you think of that normal distribution of adoption of technology, there's that chasm, that bridge. And we definitely have not jumped that chasm, right? We're still in this early adopter phase. And yet, most of the infrastructure that's out there today is breaking. There's cracks. And so this problem of scale, if we want mass adoption, if you want to see through this vision, it's impossible to join. Oh, hey. that's number one. Number two, why build an L2? Second observation, second reason. Ethereum is the most aligned in terms of this crypto maximalist vision that ecosystem and stack that's available today. So we feel it's imperative to scale Ethereum specifically. And then three, when we look at the scaling solutions of Ethereum, we really feel like there's a lot of holes that we need to fill. There's fragmentation. We have many different roll-up stacks, all of them with their own security guarantees. That state fragmentation ends up with liquidity fragmentation, and we think that potentially the answer to solving some of these problems, especially a big looming problem of coordination across all of these roll-up stacks and agreeing on standards, is actually in the past, and that's with sharding. And that's what we do with zkSharding. And so what you'll see is the first version of it. You'll get to touch it, play with it, break it, criticize it, and maybe build something at some point. So with that, I'll give it to Stepan, our VP of Engineering.
Yeah, thank you, Avi. Thank you, guys.
Can you just switch to the...
Yeah, so let me start my presentation. Today I'm going to tell you a little bit about our very high-level system design, and I'm going to explain you some concepts to help you to understand what we're going to build exactly, and I hope my explanation will help you to follow the Aleksa's workshop later, because he will refer to some concepts, messages, shards, etc., etc. So, well, roll-up, yet another roll-up in 2024. Maybe you have a question, why on earth we need to build this one another roll-up? Well, do you know how many roll-ups existing right now in the market? It's about 30 of them in production, about 15 in testnet, and many more just coming, just building. Yeah, does it work?
It should.
Yeah, well, and that's why thanks to Vitalik for that, because he said that roll-up-centric approach is the way, exactly the way that how we're going to scale the Ethereum. It was 4 years ago, and after this, all this roll-up, optimistic, zk roll-ups starting to grow like mushrooms after the rainstorm, and we have a lot of them. And well, why we need another one? It's because we have a lot of questions, a lot of issues which connected to this roll-up-centric approach, as you can see. Well, we're not really happy these issues in our industry, and we want to build this sharded system to help developers and to help the community to build your applications like in a better way. So instead of if you're facing the problem of bandwidth, you need more block space, you need more bandwidth. Instead of adding one more rollup, like your app chain or something like this, you can add something like shard to the existing system, to the existing sharded system. Well, and this is the very high-level explanation. What is our sharded system? So basically, sharding is not a new concept. It's a well-known concept in computer science. We split our state, our global state, into separate partitions, which we call shards, which everybody calls shards. And basically, every shard is a separate network. And every shard works this its own part of the state and execute some blocks. But there is one but, very important. All these shards are connected to each other on the protocol level. So you don't need any relayers, you don't need any additional tools to connect several contracts in different shards. We have two types of shards in our system. As you can see here, shard 1, shard 2, shard 3. It's so-called execution shards as workhorses of our system. So our contract codes executed in these shards, in execution shards. And we have one main shard, and main shard is basically it's a vector clock for our system. So it's in charge of tracking of latest state root of each shard. And what is L2 sharding? So if we add to the previous scheme Ethereum, our L1, and add some synchronization layer, which is responsible for synchronizing for data availability and settlement, we'll get sharded layer 2 solution, which is zkSharding. Well, obviously that in our solution, you don't need, you don't have a fragmentation of liquidity because all the liquidity will be available within the same system, but probably in different shards. You have a single validator set, and you have some rotation of validators for each shard. So each shard works with just a subset of validators, not the whole set. And well, basically, if you need to scale your app, and this is really important, you can design it in a way which your app could work in different shards. And this gives you scalability of your applications. And then you need more scalability. You just add one more shard, and then one more shard, and then one more shard. And theoretically, it gives you almost unlimited scalability. Well, let's see this picture. I want to explain how the transaction flow in our system. I'm going to use the word message instead of word transaction. It's for purpose because, well, we don't have transactions exactly in Ethereum sense, and Aleksa will tell you why a little bit later. But think about messages. It's the same idea, but let's call it messages. So users send their messages to some it's PBS, it's proposer builder separation, but let's say it's some entity which like it's sequencer basically. Well, these messages from users, they appears in mempools, and each shard in our system has its own mempool. Then shards separately in parallel read the blocks and execute these blocks in Ethereum virtual machine inside the shard. Then the block is ready, is validated. The prover network create a proof of state transition in this block, in this shard, from block to block. And then we will send the state diff and this proof by sync committee to Ethereum. Well, there is one important thing here. During the execution of block within one shard, you can see the instruction kind of a sync call to another contract on another shard, and this is a synchronous call. And this is really the big difference between our system and any other systems. Well, let's talk about this cross-shard communication because it's really important stuff. Well, first of all, this cross-shard communication, this message passing, is a part of our protocol. So as I said, you don't need to work with any other protocols. You don't need to have any additional tools. You just send the message like very natively to our network. Our network guarantees delivery of the message. Each message that it's sent is being written in the block, both in the block of shard which sent the message and in the block of shard which received this message. Well, and as I said, this message passing is asynchronous. And as you know, there is no such a thing as asynchronous communication in Ethereum. So, and this is the big problem. So you could not just say, okay, send the message synchronously in the Ethereum network, and there is no any patterns, there is no any primitives for asynchronous communication. Well, and you need to do, and we implement this flow, something like this. So you have some code execution. You will see some instruction which say, okay, I want to send a synchronous message. You need to save your context. Then you need to send the message. Another contract, another shard, received this message, restore the context, made some execution, send back the result, and in shard N, in initial shard sender, you need to invoke the result and restore the context, and then proceed with the execution. And I think that this is the biggest challenge for us, to build a system which allows you to do this easily, relatively easily and seamlessly. So this is like the big point for us, and we are going to work on these asynchronous primitives in several nearest months. Well, another very important concept is synchronization between shards. So as I said, separate shards execute their blocks in parallel, separately, but we have main shard. And then each shard finish the block, it's sent to main shard the latest state root. And each shard have an access to data of the main shard, and main shard knows the latest state root of each shard. So this is this feature, this design solution allows shard to communicate to each other, and main shard is in charge of, you know, the moving overall system forward. Yeah, well, and what about decentralization? Right now, our system is not decentralized, it's centralized, but we think about decentralization, and we already decided, and we're going to implement this, that we will have two types of consensus. The local consensus is the consensus within shard, within one shard. The subset of validators should achieve this consensus to agree that, yes, this block is valid. Well, but what about main shard? We need to have global consensus to, first of all, to shuffle the validator set, to reassign some validators to some shards, and then we need this global consensus, and each and every validators in the set should participate in this consensus to operate this main shard. Well, and the last topic from my side here is a little bit more about sync committee, how it works. Well, sync committee, as I said, it's part of the system. It's service which responsible for communication with Ethereum, with communication with our L1, and for data availability. Well, what exactly it does? It gets some updates from shards. So it gets, okay, give me state diff from some time from t-6 to t. Okay, well, let's assume that sync committee have this diff. What does it do next? It sends this diff to the prover network and asks to build a proof, the state transition proof. Then it batch all the state transition proofs and diffs and send it to Ethereum. And basically that's it. So then this data is available in Ethereum. You have data availability. Well, yeah, my final thoughts here. Despite all these challenges that we have, these sharded systems, and I'm not gonna lie to you, it's a really big challenges. I'm aware, I'm sure, and believe that we could overcome all these difficulties, and we could count this really good solution for asynchronous communication, and we could bring this sharded L2 system to life. Well, that's it from my side. Aleksa.
Thanks. So can we switch to my laptop? Cool. Hello, everyone. Can you hear me? Great. Cool. So thanks, Stepan and Avi, for doing the intro. My part will be a bit longer. And the idea is to give you to show you how you guys can build something on NIL. And by doing this, also to explain you everything that we build around the NIL. So I'll try to make it fun and to make it interactive. So I'll even maybe ask you some questions, so follow along. The first slide I had, Avi kind of took this from me, but I want to give the huge and special shout out to the whole team. I mentioned here engineering team as, I'm engineer, but overall the whole team did excellent job in the past months. So yeah, can you guys give them the big round of applause? Avi, you see how this needs to be done? So Stepan already explained you how the NIL works. Something that I'll try to do now, which I'm not sure is it crazy, but to try to do it in one slide. So just to give a recap of everything and the things that you need to know about NIL in really simple terms. So NIL is an Ethereum layer 2. NIL is based on zkSharding. What zkSharding means, so we are secured with zero-knowledge proofs. And the sharding part means that our architecture has multiple parallel VMs. So because we have these parallel VMs, we support parallel transactions. And because our VMs are EVM compatible, this means that if you already have a dApp or you want to develop a new dApp, which exists somewhere in the ecosystem, you can just take it, redeploy it to our execution shard, and it should work. But you can even go a step further because we solved interoperability by having a native cross-shard communication protocol. This means that you can, within the protocol, send messages from one shard to another. You can you can split your dApp into multiple modules, then take these modules, deploy them on multiple shards, and in that way, you can execute things in parallel. And whenever you need to sync the state or send something within these modules, you use the protocol that Stepan already explained and just have it out of the box. So this workshop is going to be about all of this. So we are going to take the sharding part, and we are going to explain you how you can build these dApps, on top of it. So I always like to start all the workshops with setting expectations. The first thing is kind of the overview. So essentially, I want to cover these 3 topics. So I want to show you how you guys can access the NIL. Then I will go to my favorite part, which are essential tools for developing a NIL. And then we'll do this NIL by example. Whoever is familiar with the Go, you know that Go has this Go by example website. You go there, you learn all the things you need to know to get started. In our case, we created a public repository called NIL by example. And as we grow, we plan to publish more kind of semi-tutorial, README files, which if you follow along, you should get understanding how to build something. How we will do it. So everything that I'm going to do, it's going to be a dual approach. So first I'm going to explain it. I'm a big Miro guy, so whenever I explain something, I try to show it on Miro. And then as well, we are going to try to do it live. I know that many people advise me not to do the live demo, but I think that we are good to try it, so why not? And for that, we are going to use some of our libraries. And the last thing is what to expect. So after this workshop, I feel that anyone who listens it will be able to build your own dApps on top of NIL. This includes both the dApps within the one shard, and also you will see how you can split these dApps in these modules and redeploy it and have the cross-shard dApps. Also, this will be the first time that you'll hear about all unique features that we built. And as well, I'm going to show you where you can find more materials. And the last thing is something that I always like to emphasize. It's you guys have a chance to be the first one who code on NIL. This means that whatever feedback you guys provide to us, it is going to influence how NIL is going to look at the end. And that's what basically the Devnet is, just hearing you guys and sharing some ideas and things we built. let's get going. So the first thing, as I said, is setup and configuration. We opened our private Devnet. I think that majority people here already got the tokens. Throughout this conference, also we created one kind of release token, which is going to be active for the next 4 days. So if you don't have token, just scan the one you see under the Devnet access. It is going to be active for the next 4 days. You can try it out. And if you didn't got the token, just scan here, and Will over there is going to help you get started. Couple things that I would like to mention regarding this topic, regarding these tokens. So we want to keep it private. So that's why each one of you have their own token. We want you guys to use it. Sometimes you will even break something in our network, which is completely okay. But we don't want this to make public. So we are also tracking these tokens just to make sure that nothing malicious is going on. If something happens, we will maybe need to restrict the tokens. But overall, we are sure that all of us have the same goal, just testing out, coding, and having fun. The next part of my workshop is essential tools for building on NIL. We are EVM compatible, but we introduced many cool things. These things that we introduced kind of broke some of the libraries that all of you are familiar and used to developing. And something that we are really trying to do, besides creating a really good protocol which can scale, is also to make the onboarding as easy as possible. That's why, for this private DevNet, we prepared a couple of libraries that you guys can use to build. So let's go and see what we have. The first one is NIL CLI. This is the command line tool for managing interactions to NIL. This CLI can be used for literally everything. It's a bit fine-grained solution, so you need to play with it a bit. But using it, you can fetch blocks, fetch messages, fetch receipts, so do the basic things you need to query the network. And you can even go further. You can deploy contracts, interact with the contracts, and so on. And lastly, it will help you to manage wallets and other things. The advice that I would give for someone who wants to build, the CLI is the best tool for wallet management. We will cover the wallets a bit later, as well as querying the network. Regarding the contracts and everything else, I would always go to other solution, which we'll cover. So for you guys to get started, you can scan the QR code. The NIL CLI can be easily downloaded with just one command. Currently, it supports Macs and Linux, so you just do the command and everything works out of the box. You only need to create the config. So here I have config YAML. Now it's actually config.ini, but everything else is the same. So you need to put the RPC endpoint. This is where you copy-paste the token that we gave you. And then you need to put the private key and the address. Private key is the private key, well, your private key. We can generate a new private key. And also the address is address of the wallet. So the next thing that we did is NIL.js. Whoever built on Ethereum compatible networks knows that there are so many libraries that assist you to kind of interact with the network. We created our own called NIL.js, which serves as a great way for you to integrate communication to NIL within your apps. It can be downloaded using NPM, so it's a TypeScript library. And this is also something that we are going to use internally to extend other libraries that you guys are used to. One of the example is probably the favorite thing for me, like from the user side, is this NIL Hardhat plugin. So who here used the Hardhat? Like, come on, guys, more? Only two? Oh, Foundry. That will be next, I promise. So, yeah, usually I have here like all the hands. But the Hardhat is the library used for deploying the contracts. It was kind of the first big library in the market that at the time everyone used. Now we have so many different and everyone choosing what's the best. But the really cool thing about Hardhat is that they offer extending the Hardhat with the Hardhat plugin. So the architecture here goes, and this explains our philosophy of building these libraries. So on this side here, you see this is where user interacts. So user is sending some requests to the Hardhat, so writing scripts, contracts, tasks, and so on. And then Hardhat is doing something. This is what we don't want to change. This is what we try to keep as same as possible. So onboarding for someone who is familiar with this should be seamless, like someone should just try to use it. How we do that? We created this NIL Hardhat plugin, which serves as adapter. So it catches all the requests that the Hardhat is sending, is doing all the changes it needs to do, nothing too fancy, couple of changes in RPC methods, so maybe name, maybe params, we use different serialization and so on. Then these modified requests are sent to the NIL cluster. And then again, when the NIL cluster returns the response, the plugin kind of adapts it to match the Hardhat interface, and then everything works seamless. So, but yes, like, how can I use this Hardhat plugin? Again, the Hardhat team did a brilliant job to allow anyone to integrate it. So the only thing that you need to do inside the Hardhat config, you just need to import it. So you download it using the npm. And then, as with every other Hardhat project, you just create a new network. Our network is called NIL. You put the URL and account, which is, well, endpoint and the private key. And the thing that we also need are the wallets. So you put your own wallet address and you're good to go. Again, now I'm doing all of this in theory. In a couple of minutes, you're going to see it in action. The last thing that we have, so we created our own custom block explorer only for Devnet. So if you want to see what's going on, if you want to see if someone is building, if you want to check your own messages, blocks, what's within the blocks and so on, you can always scan this QR code. It will open our block explorer. And this block explorer supports shards. So compared to others, it's adapted to our ecosystem. And that will be it. Now I will go to this part that we call NIL by example, where you will see me code. This is where I'll try to do it live, so let's see how it will go. Yesterday we shared the links to the repository that I'm going to do it now. You guys can follow along, but keep in mind that after my workshop, we have an hour or so to go and talk with you guys. So if you're curious to set up everything, we are more than happy to come by and just help you guys get started. So I will see how I'll do it with the mic. Maybe I will need to drop the mic, at least till I code. So as I said, we have this repository called NIL by example. We sent this repository to each participant of the Devnet, as well as open source on our GitHub. And it's kind of divided into 3 parts. The first one is the CLI. So this is where we pre-configured everything that you need to have, so all the artifacts and the config and so on. We have the Hardhat project, again, pre-initialized. It has the demo contracts, it has, the tasks, scripts, and so on. And then you have this part here, which are lessons, and this is what we are going to cover today. So in total, there are 5 lessons. I hope that I'll manage to do 4. And the 5 I'm kind of leaving for you guys to ask me, and then I to say, like, oh, I know how to explain it. So let's open this in the code. I have it here, and let's start. So the first lesson is the wallet. And as I said, we are first going to explain it in the mirror board, and then I'll do it using the CLI and Hardhat. So in Ethereum, we all know that we have 2 types of accounts. We have externally owned accounts, and we have smart contracts. And the difference between these 2 accounts, they're both the key value pairs. It's just that external owned accounts is a map where you have the user address, and on the other side, you have a balance. And this is what is used to pay for everything you do in Ethereum. The smart contracts, you have the smart contract address, and then you have the smart contract code. This is the byte code of what's inside your contract. And the user interaction goes like this. So every user has its own private key. Using your private key, you sign the transaction. This signature is kind of the proof that you are the one who sent the transaction. And then what Ethereum do, it takes the signature, and it takes the private key, so the pair of the private key that you have, it validates it. In that way, it knows that it is you, in fact, who sent it. It checks the balance, so it checks that you have enough to pay for transaction, and it just executes the transaction. This approach was really good, but over the time, the industry realized it's not really flexible. So what we want to do, we want to have account abstraction on protocol level. That's why we decided to completely deprecate externally owned accounts. In NIL, everything is a contract. So everything is just the contract address and the pair of the contract code. So now the interaction will go that we will have these kind of special contracts. They are just Solidity contracts which follow the specific structure. And the structure is like this. So you have the verify external method. This is the method where you write the code to prove that you are who you claim you are. And then you have this send message. And this is the message that once once the contract confirms it's you who is the owner of the contract, it will send this message to the network, and that's where it will get executed. So you as a user, if we want to have the same experience as Ethereum has, so you would sign this external message using the private key. Then the verify external is going to verify, again, it can be in the same way as Ethereum, and then it is going to send it to the NIL, and that's where this message is going to be executed. So to show you these contracts, I will open the code. And here you can see that we have this wallet.solidity. And you can see that it's just a simple smart contract. In constructor, I'm passing the public key. This public key is going to be used for verifying my signature. And then, as I said, every wallet needs to have verify external. This is where we are verifying that it is me, in fact, who claim I am. And using our pre-compiled, we can validate the signature. So we have the public key, we have hash and the signature. Signature is something that the user do off the chain. And once the contract verifies the user, it just sends the message to the network. And now the question comes, how can I create my own wallet? Because I need the wallet to start interacting with the NIL. If we go to this lesson MD, you will see that we prepared kind of all commands for you. And if you just follow the commands, you will be able to do majority of the things we provide. So whenever I start use any other new network, the first advice that I will give to everyone is generate new private keys. NIL is not storing anything, but just for the sake of security, using the CLI, we have a keygen new command, which is going to generate the private key. If we open config.ini, this is where like everything is, that like CLI is using it, you can see that now we have the RPC endpoint, and that now we have our own new private key. The next thing that we need to do, we need to create a wallet. So for us, we pre-compiled this contract that I just showed. And if you want to use our own contracts, currently we provide only the one that I showed. In the future, we are hoping to have much more for you guys, so you can kind of hand-pick what logic you want. You can just use this wallet new command. But also, you guys can write your own wallets. So you guys can define your own logic. You guys can deploy this contract using the hardhat or the CLI, and then can just like use it for any interaction. So what we can see here is that now we have a wallet address. As we said, wallet is just a contract. And luckily in Ethereum, it's like in Ethereum compatible networks, it's easy to fetch the code of the contract. So we have like this contract code inside the CLI. So if we just copy paste it here and run it, we should see the contract bytecode. This contract bytecode is the bytecode of this contract. Confirms us that we managed to deploy it. So the next thing that I want to know is how can I know how much tokens I have on my contract? For this, we have this wallet balance command. So you just execute it, and you can see how many native currency you have. This native currency is equivalent to Gwei, I think. In NIL, we don't have a name for it. You guys can maybe help us pick something. We had a couple of ones, but yes. Also, what if this is not enough? What if you guys start building so much that over time you spend everything? So you can either create a new wallet, or you can easily top up your wallet using the wallet top up command, where you just paste how much you want to have. In my case, I will double down what I already have. We have some restrictions, so you cannot drain us that easily. But overall, this is how you can increase the balance of the wallet. And that will be it. So next question, next topic that I would like to cover is the smart contracts. So now we finally know who is going to pay for our interaction, and it is going to be the wallet. So now let's see how I can work with the smart contracts. So I think that until now you guys know that we are a sharded system. And if we look at this shard, it is called execution shard. This is the shard which is executing the bytecodes. So you can see that it's kind of the standalone chain. So it has its own message pool, it has its own EVM, and it has its own state. So if you look only this and you exclude everything else that we have in the system, it's kind of equivalent to what Ethereum and other, Ethereum compatible chains are. So interaction should be quite similar. I should be able to just send there, interact with the contract, and so on. And that's right. You guys can use execution shards to deploy your own dApps. You can redeploy the dApps that you already have, or you can create new ones. And to do so, let's go back to editor. And here again, we prepared the commands. So for deploying the contracts, we are going to use the Hardhat. And if you guys remembered, I initialized the Hardhat project, and the only thing I had to do is here import our own Hardhat plugin. So we would have the adapter that I mentioned, which is going to catch all the requests, change them, send them, and do everything again. And I also had to declare our own network. The network needs to be called nil. This is what the plugin is expecting. So this is one of the common issues I see people do, sometimes mistype it or so on. So just keep in mind to call it nil. You pass the URL, you pass the private key, and you need to pass the wallet. So we created this .env file. Here I have the RPC endpoint. The next thing that I need to do is just to copy paste the wallet and to copy paste the private key, which I'm going to use for interaction. So let's do that. And this one. So that's it. We save this file, and let's see what we have else. So all the contracts that we are going to show in these lesson directories are going to be placed here. So for now, we are just going to focus to this incrementer solidity. It's extremely simple contract. It has just one value, it's uint, and it has two methods, the one to increase the value and the second one to get the value. And we are going to use this contract to show you how to deploy and interact. So in Hardhat, you need to write deployment scripts. So here inside ignition module, you just create a new file. Here you can create kind of, what it needs to do. You just call this m.contract, give it the name of the contract, and basically Hardhat do everything for you. So to deploy it, let's go to lessons. So we were here, and we can just use this command. So we need to do npx Hardhat ignition deploy. We give the script, so deployment script that I just showed you, and you need to specify the network. As I said, our network is called nil. So you do it here. It asks you, are you sure you want to deploy it? We wait a couple of seconds, and you should get the contract address. So let's see. This is the thing with the live demos. You need to wait a bit. We have it, good. So this is the address where the contract is deployed. And if you look at the address, you can see first 2 bytes explaining and showing you on what shard it is deployed. Our Hardhat is deploying everything by default on the shard number 1. Later, when I start showing you guys the cross-shard communication, I'm going to show you how you can deploy somewhere else. But this is the great indicator for you guys to see if something is deployed and where it is deployed. So then again, you can go to Block Explorer, check the shard, and check everything out. We can use the CLI again to check the contract of the code, just to confirm that deployment was really done. So we use again nil CLI contract code, and we just paste the code of the contract. And the CLI is smart enough to know on what shard it is, to route to that shard, fetch the bytecode value, and return it back to you guys. So the user experience is the same as if it was one shard, and we kind of abstracted the whole logic behind it. So now we need to call something on the contract. In Hardhat, we have a concept of tasks, so you can create your own logic. So what you basically need to do, you need to just kind of get the contract that you deployed, so you connect it to the account that it existed, and then, it's test, not test, tasks. So incrementer, so here, we just connected the contract, attached with the address where we deployed, and then we are going to call these 2 methods, so increment and get value. To do this in Hardhat, it's again extremely easy. So you just do npx Hardhat increment network nil contract, and we need to pass the contract address. Again, why? Because the Hardhat script needs to connect our contract with the address, and then it knows how to everything else. So let's see it. It's now sending the transaction, message over our wallet to the network. The wallet is paying for this message, and we should see as a value that the value is 1. Why is 1? Because the first value was 0. To show you that I wasn't just lucky, let's do it again and see now if the value will be increased. So let's see. Cool. We see that we can interact with the contracts. So we use this simple contract just to explain the concepts, but everything that you're used to building on Ethereum, you can build as well here. So I said in the beginning that you can also use the nil CLI to interact with the contracts. It's a bit fine-grained solution where you need to set more parameters and so on. But to show you guys that you can, I'm going to try to fetch the value using the CLI. So basically how it should work, we have a contract command inside the CLI. You have this call read-only method. You need to pass the contract address. In our case, this should be it. Then you can pass the method you want to call. In our case, the method for getting the value is getValue. But then again, you need to pass the ABI file. So CLI would know how to encode everything. So if I do it here, we should see that the value is the one that we have in the contract. So this is all cool, but this is something that you can do in every other chain. So what is, like, how we can build on top of this and add the sharding in the system. So if we go back and now check another picture, we can see that here I added a couple of contracts. And this is the situation, the scenario that I'm going to show you live. But let's first see what we have. So on the shard 2, and how you can know that it's on the shard 2, you can see by the first 2 bytes. You can see that we have the contract called caller. And this caller has a really simple method called call. To do all the cross-shard communication in our system, we created the pre-compiled contracts. But we don't want you guys to know like that you guys need to go in our protocol, read our pre-compiled contracts, and need to see how to interact with it. Because of that, we also created the Solidity library. So you can just take the Solidity file, it kind of extracts the whole logic. And then what you as a user can do, you can just do, using our library called nil, do the async call where you put some params. Basically, you need to put the destination. Using the destination, it will know where to send on what shard. And here, you can encode what you want to call. Here, I encoded to call only the increment, but you can do actually any cross-shard message that you can think of. Then, as we already deployed, so on the shard 1, we currently have this incrementer. And the whole idea is that this caller is going to call this incrementer, and in that value, increment everything. So should we try it? Let's go. Let's open now the lesson called cross-shard communication. And just for the sake of tidiness, let's stop everything else. Let's close everything else. Again, we prepared the contracts for you. So we said that first we need to deploy the caller Solidity. So again, just so you guys see the caller Solidity, so it's importing the nil.sol. You can find it, I believe, on our website. It's simple library which extracts this communication with the pre-compiles. So this caller contract is just like, as I said, has only this call method. You set destination address, and it's going to do this increment. So let's deploy it. We can again use the hardhat. The only thing that you need to change is here in the hardhat config. Are we there? Yep. We need to do shard ID. And for the shard ID, we need to put the shard ID where we want to deploy it. So if we save it now, and we do this command, let's try it, we should see that this contract should be deployed on the shard 2. So it will take a couple of seconds again. Let's, by that time, prepare this terminal. Cool. So we see it works. And how we know where the contract is deployed? Again, you can see it here. It's on the shard 2, compared to the first contract, which was deployed on the shard 1. So to interact over it, now there is a small catch. And the catch is that everything that you're sending, you're again sending over your wallet. So whenever you want to interact with some other contract, first the message needs to come to the wallet. Then from the wallet, it needs to come to some destination contract. And this destination contract can be on the same shard as the wallet or on another shard. Because our wallet is also deployed on the shard 1, because we didn't change by default, the nil CLI is deploying on the shard 1. For hardhat to be able to fetch the receipt, it needs to know where is our wallet. So we are just going to revert this back so it will know to fetch everything from the shard 1. So if we go back, Now let's do the async call. So again, we are just going to call the task. We have the task here. This task is again really simple. It just connects with the contract that we deployed. And after that, it is going to call the method which is called call. And it is going to pass the destination contract, which is, well, where our incrementer is. So to do so, let's do it here. And I'm going just to paste this. Then, as we said, we first need to put the caller contract. Then we need to put the incrementer. So this is the destination contract. And then we have here the incrementer. And just to double check, because this is the issue I do like the most, here we return the shard ID. And here, if we start it, we should have successful async call. Let's again wait for a couple seconds. So what's happening under the hood? We are sending the external message to our wallet. Our wallet is sending cross-shard message to the caller. Caller from the shard 2 is sending cross-shard message to the shard 1 again, and we should see that incrementer got increased. To see it, we all knew that a couple minutes ago, incrementer was, I think, 2. So if we now fetch the value again, and let's do it together, and then we get the value, we should see, oh, did I mess something? Oh, give me a second, let's do it again. So I had a command just a second ago. It's this one. Cool. We can see that it's incremented. Again, just for the sake of not being a fluke and to show you that it really works, let's do it again. And in a couple seconds, everything is doing again. And we can prepare the command to fetch the value. And once it's here, let's go here and we see 4. So this now opens the questions, what I can do with this. Something that we are aiming for is to provide you guys the full async communication. Something that we'll try to reach is that to be kind of, async await. It's really hard to do it in blockchain, but that's something that we're striving towards. Currently, we have this callback pattern. So because we can send these relatively really fast messages, and also we know we have a guarantee that they are going to be delivered, what you can do, you can send a call, you can send a async call from one contract to another. This here is atomic, so this here is going to be executed atomically. The new message is going to be created. It is going to be sent here on execution shard 2. Then it can do something, fetch some value from my other module and so on. And once it finalizes everything, it can return it back to the shard 1. And here you can have some action that you can do with it. And that's basically how you can continue building upon this and trying to build new dApps with these new systems. The last topic that I would like to cover is the general tokens and how we support the multi-currencies. For this, I will go back to this architecture and in a couple of words, try to explain you what is the issue with ERC20s on this system. So we all know that ERC20 is nothing less just a smart contract. And the issue that here happens is that if you deploy the smart contract on a specific shard, this means that whoever needs to do something with your token needs to send the message to the shard, then back to you. Something that we managed to do and something that we are going to build and continue working on is adding the multi-currencies within the protocol. So every contract, besides the native currency that we saw, can also support multiple number of multi-currencies. So far, we have the CLI, and CLI can manage and interact. And to show you how everything works, for the last time I promise, we will go to these lessons, and we will open the multi-currencies. We will close everything else. The only thing that we are going to need is this config, because we will need to have multiple wallets. Let's clean also everything here and here as well. So let's open this on the side and let's try it out. So if you wish to create a new currency, inside the CLI, you have nil CLI create currency. So you just do it. You need to put the owner of the currency. In our case, let's say that this is our wallet, the wallet that we used. You need to put how much how much tokens this currency is going to have. Then you should put the token name. We can put dev token as a Devnet token. And then what you can do, you can use this withdraw flag, which is going to, once the token is created, and we are creating the contract using the pre-compiled contract called Minter. So we also want to get these tokens to our. So basically what will happen, the Minter token is going to, the Minter contract is going to create a new token called dev token. It is going to have like this amount of tokens, and it is going to be sent to our wallet. So let's do it. So here we can see that we created a message. Message is going over shard 1. And here we can see that we created a dev token and how much tokens we have. Also, something that you should pay attention is that every token is not mapped using the name, but unique ID. So for you to interact with your token, you need to keep track of your IDs. So for this, now I'm going to save everything we have. So first, let's save the wallet 1, the wallet that we used to create it. And here we can save the address. And then again, for the wallet 1, let's say save the ID as well, and just save it here. Oh, let's save it here. So what else we can do? So using the CLI, you can get all the currencies from any contract we have. So if you go nil CLI C config ini contract currencies, and just copy paste this and put any contract address. In our case, I will use the wallet because that's where we created the currency. And I do this, you can see that we have it for real. And now comes the difference between these currencies and the balance that I showed you. So the balance are the native tokens used to pay for all interactions in the network. Whenever you deploy the contract, whenever you send the message, whenever you send the async message, it is not going to be deducted from these multi-currencies, but from the balance. These multi-currencies are just a way for you to have multiple currencies and then build on top of it, send it, build different standards, and so on. So using the wallet balance, as we showed in the first tutorial, you can see how much your wallet has. But also, something that I didn't show while I was showing the wallets, using the CLI, you have a way to send the native currency from your wallet to somewhere else. So you can use this nil CLI wallet send tokens. And you need to put destination contract and amount. So now I realize that I don't have a wallet where I can send. So for it, let's go back to the lesson 1 here, and let's create a new wallet. So we can use the same command we used. The only issue is that if we try to do it, it will fail. It will fail because we are calculating every address of the contract using 3 params. It's contract bytecode, it's shard ID, and it's a salt. Salt is a random value that you as a user can put so you can deploy the same contract multiple times. Because the CLI has a default value of salt, if I try to execute the same command on the same shard with the same bytecode, the address is going to be same, so we will have the collision. But because of it, you can just add a flag, salt, where you can put any random value, and it will create a new contract address where a new wallet is going to be deployed. So here in a couple of seconds, we should see that we have a new wallet. Here we have a new wallet address. And here, I believe that also the CLI is going to update the address for the CLI. That's why I had to kind of, copy paste the old one. So because we are working again, we have the money in the first wallet. Let's save this one again. So here we have a wallet 2. And that's it. And for us, for interaction, so the CLI is always using the wallet, which is inside this address field. So where were we? So we wanted to send tokens from one account to another. So let's do it by, again, using this command. So nli wallet send tokens. We can specify the destination address. In our case, the destination is going to be the new balance. And the value can be any value we want. So let's see, again, we have a message. This message is going to do the transfer of value between the 2 contracts. And we see it's successful. So for us to check the balance, we can use the contract balance. So let's just go here. Let's use the balance. And let's see what we have. So we have this. So you guys can either trust me that the balance decreased, or we can do it again. So let's put a bigger value, and let's try to decrease it even more. And once this message is finished, we should see the difference between before and after inside our balance. So let's see it. Great. You see that these two values are different. You have 9 here, you have 8 here. This means that we managed to transfer. If we would check the balance on destination contract, we would see that it's increased. And to do that, we can just copy-paste the address of the new wallet here, and now check this balance. And yeah, it's not the default one, so it got increased. And the last thing that I want to show is that besides just transferring the native currencies, what you can also do, you can send these multi-currencies that you have within the contract. To do so, you again do the command set tokens. Again, you have a destination, and you can put the native currency, how much you want to send the native tokens. But then as well, you have a token flag, where you can put how many pairs of ID and value, so currency ID plus the value of the currency, to transfer it. So let's try it out. So here, I will return the old wallet, because this is the wallet which holds the currency. Here we have nil CLI send tokens again. Then let's again put the destination contract, which was one here. Let's also send some native tokens. But now, besides the native tokens, we are going to add the token. Is it token? Let me just double check. Yes. And then we are going to use the token that we deployed at the beginning of this lesson. Put equal sign to, let's say, 1,000. And once we execute this, let me see if I did it correctly. It should work. So now, if I would use the command to check what are other currencies in this contract, I can again use the CLI. Then inside the CLI, I just paste the destination contract address. And we should see the token. As you can see, now it has the 1,000. So that will be it. I hope that you guys liked the practical part, that now you guys finally see what you can build. And we hope that you guys will test it out, that you guys will come to some cool ideas, that we'll work together in the next 6 weeks. And this is a good intro to my next slide, which is our Devnet cohort. So this is the program that we created for our private Devnet. The structure of the program goes that the whole July, we will try to educate us and to explain you some concepts. So there we will also do like some more advanced, sharding system stuff, where guys will explain you, our researchers are going to explain you some of the issues with sharded blockchain systems. Then as well, we'll do a couple of these workshops where we'll extend this and show you how you can build. And then in August, we would like to see you guys try it. So I think that all of you have the access. So kind of the goal and something that I would like to see is honest feedback. So if we are doing this private DevNet, we, as Avi said, and he said it's really good, like we want you guys to see, build it, break it, destroy it, however you want. But this is what we need. This is what we appreciate. This is what we would like to see from you guys. Just like kind of, the honest feedback from what are the libraries which are missing, what are the things we need to work on, what do you think would be cool for this approach, and so on. The last thing is where you can find us. So you can meet us at the booth. The whole conference here is a booth. So the whole team is here. We have researchers. We have, the product, technical, and so on. So if you're curious about any aspect of NIL, this is probably the best time to ask. So just approach us and ask any question. But if you cannot make it, or you need some help after hours, we have our Discord channel, we have our Telegram channel, and we have the guys online almost all the day, all night, who are more than willing to help everyone. And this will be all. The last thing that Will asked me to mention is just to use our Telegram chat. So we have a Telegram chat for this DevNet. if you have any questions, if you want to learn more, you can also go there and, yeah, just contribute. That will be all. So now that I finished the workshop, if you guys have any questions, you can ask them. But I will wrap up the presentation and come to you guys and we can discuss in private. So that will be all. Thank you. That's a great question. So, yeah, I'll just answer it here publicly. So the question was, how does the transaction flow goes when someone sends and wants to do the async communication? So basically what will happen, you as a user, you want to execute something here. You create a message, you send it to the wallet, wallet creates a new message within, and then the wallet sends this message to the shard where the contract is. So here you can see that this message is going to be in the message pool of the shard 2. Once it's time for this message, it will execute something here, and our precompiles creates a new message. This new message is going to be sent directly to another shard. Again, it will be in the message pool, and then from this message pool, it will be executed. I think that the guys from the research, Ilya, can give you more about these transactions, when they are going to be executed, and so on. So if you guys want to extend it, it's your time. Oh, okay. Yeah, so I hope I answered your question, man. So yeah, basically the transaction is sent to the message pool, and when with the current implementation, when it's the order of transaction, it's going to be executed on destination. Sure. Yeah. Cool.
Second question was that for this, like, this ability to have like multiple currencies. So for this ability that you have to have like multiple currencies directly built into the protocol, like which you're doing with the precompile, like where is the balance of this? Is this in a specific shard or this state directly part of the main shard?
Can someone from the research help me with this answer? Or Stepan? Like the idea between the native currencies and the multi-currencies, that they can be easily shared within the shards. So across all the contracts, in all the shards, you can have these IDs, and within the protocol, you can send them, on all the shards without issues. So there is no centralized place where they're all. They can be shared on multiple contracts, multiple shards, as far as my knowledge goes. And then you can just, transfer them between the contracts on different shards or within the same shard.
Okay.
Cool, thanks for questions.
In this architecture, there is a main shard, right, that hosts the wallets?
No. So yes, so Stepan covered the purpose of the main shard, but in terms of the wallets are on any shard you want. In my case, the CLI is deploying by default on the shard 1. If we go back again to here, when you want to create a new wallet, so let's just go here, new, and go on help, you can see that you as a user can specify salt. I explained why we need it. No, then you'll need to trust me. So you have a command which is shard ID, and when you're deploying the contract, you just specify where this shard needs to be. But from the user side, like all the messages can go on each shard. How I would say it is that you deploy your wallet where you are kind of interacting the most, because it's much faster to send the inner shard message than to do the cross shard. So it's, but you as a user can also have multiple wallets. And because we offer the transfer of values between contracts on multiple shards, you can also send easily between multiple wallets. And yeah, I hope I answered the question. Cool. Yes. Yes. So this is, Yeah. Oh, we have it. Cool. So we have this default wallet that we created for this example. So if we go in lesson 1, assets, wallets, you can see that this is just a contract. Like you guys can define whatever contract you want. Couple of things you need to follow is you need to have a message which is delegating the message, and you need to have a way to verify. In this example, as I said, verification is the same as external loan accounts. So users sign something with a private key. Here, the signature gets verified using the public key. This public key is set in constructor, but we don't limit you to how this wallet needs to look. We just have, like, we just started, we are the sponsors of one hackathon on this event, and one of the goals that we would like people to see built are different types of the wallets. So to show us what you can build, how you can extend it, and so on. MetaMask is a good question. So we are currently looking and working on MetaMask snaps. This is the way for us, again, to do the similar thing as we did with the Harket. For you guys to look everything extremely similar, and we extract the whole logic under the hood. So in the future, we are going to publish our own MetaMask snap, which users can use to interact with the wallets. Nil-specific RPC, I believe. Yes. Cool. Do we have more questions? Does anyone want to set up and try this locally? Nope. Then I would say that's all from me. Thanks, guys.